According to the widely accepted theory, approximately 13.8 billion years ago, a Big Bang occurred that gave rise to everything we know now. It is believed that at that moment our entire universe was born, which subsequently formed into what we see today. However, before the Big Bang, there may have been nothing or something that we cannot even imagine. We will try to understand what was before the Big Bang. The Big Bang is a widely accepted cosmological model that describes the early development of the universe, beginning with the expansion of the universe, which was in a singular state before that. As for this singular state, it is sometimes characterized as a cosmological singularity. It was the state of the universe at the initial moment of the Big Bang, which was characterized by infinite density and temperature of matter. To understand what happened before the Big Bang, we turn to some theories that directly relate to the explosion itself. According to one of them, at the moment of the Big Bang, the universe could have been extremely small. It could literally have been a tiny point. Some scientists believe that everything we have in the observed universe today, this sphere with a diameter of about 93 billion light years, containing at least 2 trillion galaxies, was a tiny point. All today's galaxies were as if squeezed into a space smaller than centimeters in diameter. However, this is not the only version. According to another theory, the universe could already be infinitely huge beyond the observable universe. There may be much that we simply cannot see because it is physically impossible. Therefore, it is possible that the universe was tiny or infinitely large during the Big Bang, because there is no way to see what remains beyond our visibility. The essence is that space itself is expanding, so everything that was beyond the tiny point from which the universe was born will remain outside of our reach. Yet, what existed before the Big Bang is undoubtedly one of the most global questions that people have been searching for many years. In fact, there is no one answer, and probably cannot be one because we simply cannot fully understand it at present. Therefore, there are only various theories describing possible processes that occurred before the Big Bang. For example, Stephen Hawking believed that there was absolutely nothing before the Big Bang. He said that if we rewind time by 13.8 billion years, the entire universe would be represented by a single atom. According to his words, if the universe is expanding as we move forward in time, then if in theory we could reverse time, it would start to contract and compress, which should not be confused with technological singularity. Inside this very small, massively dense spot of heat and energy, the laws of physics and time, as we know them, cease to function. In other words, time, as we understand it, literally did not exist until the universe began to expand. There's also a completely opposite version, according to which, before the Big Bang, the universe was an infinite space made of dense material, which remained in a stable state until something disrupted it. When this dense space lost its stability, a big explosion happened, which was of a super dense universe. It was possibly controlled by quantum mechanics, and after the big explosion, classical physics became the main driver of the universe's evolution. This theory explains the existence of space before the big explosion, but what about time? According to one point of view, time did not exist before the big explosion. Neither did space. However, in 2018, British cosmologists from Oxford University, led by Professor David Sloan, conducted calculations. The calculations showed that space and time did exist before the universe was born. David Sloan said, "We are not introducing any new concepts or changing the theory of relativity, just the interpretation of some of its postulates. Our calculations show that the Big Bang was not the beginning of time, but just a change in the orientation of space. In other words, it was space that broke, not physics." Elephant and his colleagues came to this conclusion while trying to find an answer to one of the most important questions in history: what the universe looked like in the first moment after the Big Bang and how it appeared before the cataclysm that gave rise to everything Today, as scientists explain, there are two approaches to this problem. For example, cosmologists believe that the universe was born from a singularity that began to rapidly expand in the first moments after the Big Bang. However, astrophysicists believe that the birth of our universe was preceded by the death of a progenitor. which likely occurred as part of the so-called Big Bang. Either way, both of these versions are almost impossible to prove. If we turn to the first theory, the very existence of some form of space-time before the Big Bang raises a multitude of almost insoluble questions. For example, it is not clear how this form could have given rise to an energetically pure and new modern universe. Another problem is that at present, cosmologists cannot even speculate about what this old world and old universe looked like. The issue is that the theory of relativity ceases to work at extremely high energies. The energies characteristic of the Big Bang and the singularity that created it have led scientists to debate what laws govern the universe's existence in the first moment of its new and final seconds of its old life, if it existed at all. Many cosmologists and astrophysicists, including the aforementioned Stephen Hawking, prefer to sidestep this question and do not assume that time did not exist before the Big Bang. Therefore, the problem is meaningless. However, David's team proposed a new interpretation of this mystery that resolves the question of the old universe's existence in an original way, without violating Einstein's postulates or introducing any new complex entities, such as strings or quantum loops. They focused on one simple thing. While inside the universe, we cannot precisely measure its dimensions and compare it to something beyond its boundaries. Therefore, all the quantities and phenomena described by the general theory of relativity and other cosmological theories are relative. The notes that this is a simple idea that allows scientists to circumvent practically all of the unsolvable problems associated with infinite energy density and the curvature of space, which cannot be explained within the framework of classical Einsteinian theory and the space-time structures associated with it. Guided by this idea, scientists have built a computer model of a dimensionless universe and studied what the starting point of the Big Bang looks like. It turned out not to be a singularity, but a different structure, which the elephant and his colleagues called the II point. In contrast to the Big Bang's fabric of spacetime, the fabric of spacetime does not cease to exist after its birth. Rather, it becomes mirrored. In other words, before its birth, as calculations by British researchers show, spacetime simply becomes mirror-like. In other words, before the birth of the universe, time flowed in the opposite direction and space was oriented and represented somewhat differently. According to scientists, these transformations do not contradict the theory of relativity and do not affect matter itself. Essentially, only the map of its distribution changes, not its internal content. The elephant's innovative theory explains not only the principles of the operation and existence of time and space before the Big Bang, but also the absence of antimatter in the universe, as well as some other peculiarities that scientists are currently debating. The next theory, the Big Bounce, partially resembles the previous one. The theory suggests that a small explosion, or rather a big bounce, contributed to the birth of the universe, caused by a peculiar interaction between the old and new universe a long time ago. In medieval India, some religious philosophers taught that the universe undergoes an infinite cycle of creation and destruction, developing from undifferentiated mass into a complex reality before destroying itself and starting over. Some modern scientists have arrived at this same idea with striking parallels, believing that instead of a Big Bang, the universe expands and contracts in a cycle, bouncing back each time it contracts to a certain size. The theory of the Big Bounce is partially similar to the previous one. According to the theory of the Big Bounce, each cycle starts with a universe that is not as small and smooth as the singularity. It gradually expands and becomes lumpy and deformed over time. Eventually, it reaches a point where it begins to break down and gradually smooths out, decreasing in size until it reaches its initial point. In this way, the Big Bang is like the beginning of the expansion of a new universe. Specifically, it is an explosion of singularity from nothing. In other words, the Big Bounce theory suggests that our universe is constantly being refreshed by these cycles. This means that before everything appeared, there was simply another universe that had reached the final stage of its cycle and had compressed to its original size, giving birth to the new universe that we can see in the observable universe, In any case, whether it was a big bang or a big bounce, the question of what existed before our current universe remains open. None of the above theories is 100% accurate. They are all just theories. Perhaps one of them is correct, or perhaps they are all far from the truth. Maybe there was nothing before the Big Bang. Perhaps there was a whole universe, or even time and space, or maybe there existed an entire sea of universes, each with their own laws and physical properties. Perhaps we will never be able to answer the question of what existed before the Big Bang. It is likely one of those questions that has no answer, at least not yet. However, it is not impossible that in the future, science will advance to such an extent that it will be able to answer this question and provide a complete picture of what happened before the beginning of the universe. It is also possible that future generations of scientists will delve even deeper into this topic and find answers to even more complex metaphysical questions. For now, each of us can only speculate and choose the versions that resonate with us. Please leave your thoughts in the comments section, and if you found this interesting,
Supermassive black hole is the largest known genius among scientists and probably the rarest celestial body. Supermassive black holes typically exist in one galaxy, but not in all galaxies. Hello everyone, here's where these supermassive black holes come from. Let's find out together, starting now. According to existing astronomy and physics, it is known that standard black holes appear when particularly bright and massive supernovas explode. Theoretically, the mass of these black holes ranges from 30 to 50 times that of the Sun, but in reality, there are many that are much lighter. Black holes with hundreds or thousands of times the mass of the Sun have not yet been discovered, and only a few candidates have been proposed. This is known as the intermediate mass black hole problem. The main character of this discussion is the supermassive black hole, which has a mass of tens of thousands to millions times that of the Sun. Its origin is one of the most interesting problems in astronomy and physics. In reality, there are no stars of this size, so where did they come from? The relationship between supermassive black holes and galaxies is also fascinating. These black holes are typically found in the center of galaxies, but the existence of galaxies without supermassive black holes is known. However, supermassive black holes without galaxies have not yet been confirmed. The formation of galaxies and supermassive black holes is a problem similar to the chicken and egg problem. Which came first, the supermassive black hole that gathered matter around it, or the galaxy that formed first and had a black hole at its center? There is still no consensus on this issue. So where did they come from? The biggest problem in the formation of supermassive black holes is that it is not enough for a massive amount of matter to gather at a single point. To increase the mass of a black hole by having a large amount of matter fall into its singularity, it must rotate very slowly. Otherwise, an accretion disk will form around the black hole, and that will be the end of it. Of course, it is possible that the matter in the surroundings could be consumed by a black hole, but it is not very common for it to become a supermassive black hole. To understand the most likely explanation for the formation of these supermassive black holes, we need to look back in time to the distant past, around 550 million years after the Big Bang, during a period known as the Dark Ages. During this time, the universe was filled with hydrogen and helium, and was not yet transparent enough for light to pass through. It is believed that the first stars began to shine during the end of the Dark Ages and the following cosmic dawn. As the first stars appeared, matter was consumed and transformed into starlight, gradually making the universe more transparent and bringing it closer to its current state. Generally, the universe during the Dark Ages was a cradle of a giant star, meaning it was a gas or dust cloud where new stars were born. The existing theory is that dark matter actively participated in this process. As dark matter gathered material through gravity and began to surround it, galaxies were formed in no time. At the center of this fence, the density of material is very high, and it is said that primitive stars, which weigh more than 20 times the mass of the Sun, were formed massively at this time. For various reasons, these stars seem to have been very unstable and began to collapse rapidly without exploding. When a supernova explosion occurs, it collapses and becomes a black hole or neutron star. Although it is only a tiny fraction of the matter that was concentrated in the building, when a primitive star collapses, it becomes a black hole in its entirety. Then, these black holes merge, creating a supermassive black hole. Some modifications have been added to the theory through recent research. Many scientists currently believe that there was no merger between black holes, but instead, a single primitive star with a vast mass ranging from tens of thousands to millions of times the mass of the Sun was formed in the galaxy. It is difficult to imagine what process might have taken place since such stars do not exist in the universe today. Perhaps these primitive stars began to collapse silently for only a few thousand years. Although this hypothesis seems to make sense, there are several unexplained phenomena. One of them is, as mentioned earlier, that most of the supermassive black holes have masses of hundreds of millions or billions of times that of the Sun, not just thousands of times. For a black hole to become this massive, according to the hypothesis of a collapsing primitive star, it must absorb an enormous amount of matter in a very short astronomical period, many millions of times its own mass. However, in reality, black holes do not continue to grow infinitely because the surrounding matter is almost exhausted. The remaining matter becomes part of the accretion disk and does not fall into the black hole. The first black hole was hypothesized to solve problems with existing theories, and scientists attempted to use new theories, such as the primitive black hole theory. The key point of this theory is that some black holes were not originally related to stars and never were stars. These black holes are believed to have formed shortly after the Big Bang. At that time, the universe was very hot, dense, and rapidly expanding. In this situation, the space itself was moving in a different way from today. It is believed that the unevenness of space, or pockets of space distortion, may have compressed matter and caused collapse. There were various masses in these primordial black holes. The smallest black hole was only about the size of the Planck mass, which is very small at 1/1,000,000th of a kilogram. This type of black hole may have collapsed quickly and no longer exists. On the other hand, there is a possibility that the largest black hole was thousands of times the mass of the Sun. This is the type of black hole that we find most interesting. These primordial black holes had an incredible density of matter. There is a possibility that it absorbed a massive amount of matter in a short period of time and grew to a size close to that of a supermassive black hole, which then gathered surrounding matter and facilitated the formation of the first galaxies. Currently, no new primitive black holes, supermassive black holes, or new galaxies are formed in the universe due to changes in matter density. However, there are weaknesses in the theory. For example, in a very compact universe, a young supermassive black hole may have grown rapidly, but it is unclear why it did not absorb all or most of the matter. Additionally, it is unclear why the universe entered a dark age in this scenario. Matter did not just scatter throughout the universe, but rather it was originally gathered in galaxies. However, if we assume that the natural formation of supermassive black holes was possible not only immediately after the Big Bang but also during the following 500 million years, we can solve this problem. Currently, there is no hypothesis that can explain why there are no supermassive black holes present in all galaxies. It is possible to guess that this could be due to a lack of matter in dwarf galaxies, but even in the Triangulum galaxy, the largest in our local group, there are no supermassive black holes. Therefore, a theory that can explain all of these phenomena will emerge in the future. Thank you for watching until the end. I hope you enjoyed the video. If you did, please subscribe to the channel, leave a like, and share the video on social media to help promote science and space. If there was one of the brightest and most destructive phenomena in modern space, it would be a supernova explosion. Hello to all of our viewers. In this video we will introduce particularly interesting things from supernova explosions, not scientists. We will skip the lengthy introductions and get started. LMCN49 is a supernova that exploded about 5,000 years ago in the Large Magellanic Cloud, a companion galaxy to our Milky Way. Unfortunately, it cannot be seen from Earth because it is about 160,000 light-years away. However, if the supernova had been closer to Earth and existed during ancient times such as the Sumers in the southern hemisphere or ancient Egypt, it would have been recorded as the first supernova explosion in history. LMCN49 is believed to have been a very bright and massive unstable star. Supernova explosions are a profound phenomenon, and one that is clearly displayed is G1.9 plus 0.3. This supernova explosion is the most recent of this type of event to occur in the galaxy. The supernova exploded in 1899. Imagine, the 20th century was a time of dramatic scientific and technological advancements, as well as social and political upheavals. Now, well into the 21st century, there has not been a single supernova explosion among the trillions of stars in the galaxy during this period. Is the universe laughing at us? Scientists sometimes have such thoughts, and G1.9 plus 0.3 is one of the pieces of evidence. Although the supernova explosion occurred at the turn of the 19th and 20th centuries, we did not realize it. In fact, the supernova was hidden in dense gas and dust clouds near the center of the galaxy, and even with the technology of the time, we could have obtained a vast amount of valuable information. Needless to say, our technology has improved dramatically over the past 123 years, and that technology is being used to investigate supernovas that are difficult to observe in other galaxies. Supernovas appear as neutron stars or black holes covered in gas and dust clouds, just like other supernovas. Interestingly, these clouds continue to expand at an enormous speed of 15,000 kilometers per second. At present, the clouds have expanded to a size exceeding 2.5 light-years. This hypothesis may or may not be confirmed, depending on whether a similar presence is found near Earth. Located in the X-ray region, the constellation of Andromeda is one of the brightest celestial bodies, emitting very powerful radiation that can be likened to the Chernobyl disaster. As you may know, the radiation zone located 7,000 light-years away from the Sun is the remnant of a supernova. The gas cloud in the constellation of Andromeda, known as RxJ 0822-4300, is actually the core left over from a neutron star after a supernova explosion. After comparing the velocities of this object and the surrounding stars, it was found that it was moving at an exceptional speed compared to other objects that had been measured, with an estimated speed of 1,300 kilometers per second moving away from the point of the supernova explosion. The reason why neutron stars reach such speeds is unknown, but it could be a unique characteristic of the explosion. It is also important to consider that the explosion occurred about 5,000 years ago, and the acceleration may have decreased over time. How fast was it going at the beginning? The supernova SN 1054, which gave birth to the Crab Nebula, became famous for this reason. First, scientists discovered the Crab Nebula and then calculated that the supernova that created it exploded around the 11th century. Afterwards, scientists discovered a record of a bright star suddenly appearing in the same place where the Crab Nebula was discovered in ancient Chinese documents, which was a great triumph in astronomy. Behind this shining success, there was another quiet supernova. SN 1006 exploded 48 years before SN 1054 and was even brighter and better documented in historical records. While only the Chinese realized the significance of SN 1054. However, SN 1006 was recorded in documents from various regions of the Eurasian continent, including Switzerland, Egypt, and China. Arab astronomers reported that the celestial body shone brighter than Venus, while European monks claimed that the star not only changed in brightness, but also in size, expanding or contracting, and sometimes even disappearing completely. The explosion of SN 1006 occurred in this vicinity, and even after a millennium had passed, the diffusion rate of the gases released by the explosion was still remarkably high, at a speed of 9,000 kilometers per second. The power of the explosion must have been beyond imagination. There is another supernova that has expanded human knowledge of the universe, and that is SN 1572, which occurred in the Cassiopeia constellation in 1572. The history books of Europe and the Arab East contain detailed descriptions of this remarkable star. The name of this supernova comes from the famous Danish astronomer Tycho Brahe. However, he was not the first person in Europe to discover this supernova, nor was he the first to record its appearance in detail. But he studied stars in much greater detail than any other scholar in the world at that time. He succeeded in measuring the parallax of this celestial body, which was a significant accomplishment at the time. According to the observation methods at that time, Saturn was considered to be the farthest planet from the Sun or the Earth. However, through simple calculations, he discovered that this supernova was much farther away than the Moon or Saturn. In this way, humanity first became aware of how vast the universe is and how far stars are from us. There is another excellent discovery that has advanced astronomy. It was made by two contemporary British scientists, Thomas Digges and John Dee, who discovered the same nova. Using data from Tycho Brahe and their own measurements, they overturned the 1,000-year-old image of stars being located on celestial spheres, and speculated that stars would be spread throughout the universe. Perhaps no astronomical phenomenon has had such a significant impact on the development of scientific knowledge as Tycho Brahe's supernova. Furthermore, compared to the standard of the nova, there is nothing particularly exceptional about it. Scientists discovered that this celestial body was the result of a white dwarf star exploding in a close binary system. This is one of the mechanisms for supernova explosions, similar to when a massive and bright single star explodes at the end of its life. Another star forming a binary system was also discovered. This star, similar to the Sun, is surrounded by clouds formed by the explosion. Thank you for watching until the end. If you enjoyed the video, please don't forget to click the subscribe and like buttons and share the video on social media. The observable universe spans an area of approximately 90 billion light-years, and it can be assumed that the part of the universe we cannot observe is much larger. The cosmos is so vast that the human mind is simply unable to comprehend it, at least for now. However, according to some theories, it is possible that the universe is significantly smaller than it appears. According to current estimates, the unobservable part of the universe may be around 20 trillion light-years in diameter. Just imagine, based on the data we have, we can assume that most of the cosmic space should be empty because the amount of matter in the part of the universe we have explored is relatively small. When we gaze into space, we see vast, incomprehensible expanses of icy emptiness. But what if the universe could fit in one atom? It may sound absurd, but don't dismiss this theory too quickly. It is more like philosophical science fiction. It may not be so unbelievable, but first, let's recall what we know about matter. Any matter is made up of the smallest particles, atoms. These tiny building blocks of the universe, as we know it, are so small that even with the help of the most powerful optical devices, we cannot actually see them. Interestingly, we cannot even know with sufficient certainty what they look like. We can only speculate based on scientific theories. However, it is considered a proven fact that atoms cannot be seen with the naked eye, and the fact that atoms themselves consist of smaller subatomic particles such as neutrons, protons, electrons, and quarks is now well established. Atoms are so numerous and small that the body of an average adult human being consists of approximately 7 octillion atoms. To put this number in perspective, it can be represented as a 7 followed by 27 zeros. Just imagine this amount, but the atom itself also has its own structure, a complex structure that allows us to contemplate the incredible theory of the microuniverse. How does an atom look like from the inside? From your high school chemistry class, you probably remember that an atom consists of a nucleus formed by protons and neutrons and electrons moving around it. This model, proposed by Ernest Rutherford in 1911, was named the planetary model of the atom. Indeed, the analogy between the movement of atoms around the nucleus and the movement of planets around the sun is evident. Moreover, this model has not been refuted and is even confirmed by modern research. It turns out that the movement of electrons is described by the laws of quantum mechanics rather than classical physics. Thus, the smallest particle that forms the basis of matter has a structure similar to that of the solar system. Is this a simple coincidence due to the laws of physics, or does this similarity hide something bigger, something much more fantastic? We will return to this question later. For now, try to answer the question of how many galaxies there are in our universe. It sounds absurd, doesn't it? Such a number cannot be processed even by the most powerful computer, let alone the human brain. But what if I told you that there is only one electron in the entire universe? This hypothesis, called the one-electron universe theory, was proposed by American physicist Richard Feynman, and it sounds like pure fantasy. According to this theory, there is only one electron in the world that moves through space and time so fast that it appears to us as if there are many of them, giving shape to everything we consider to be the entire universe. What do you think of this? Of course, this theory has not found many supporters, but the most interesting thing is that due to the principle of identity, it is impossible to experimentally distinguish one electron from another is impossible. This paradox cannot be refuted. But let's return to the structure of the atom and the incredible theories it gives rise to. Let's try to answer the question of what size objects are. Despite the everyday, familiar meaning of this word, the concept of size is quite mysterious and relative. For example, the world around us is adapted to our size because we built it. But with the creations of nature, it's not so simple. Mountains are huge for us, planets are gigantic to the point of being impossible to comprehend, but for an ant, all forms of life range from simply small to microscopic. However, do ants consider themselves small and understand that they live in a world of giants? Probably not, as their world is just as familiar to them as ours is to us. Compared to cosmic objects, we are even less than microscopic. This thought gives us goosebumps, and it's no wonder that the great master of horror and science fiction, H.P. Lovecraft, promoted the idea of the insignificance of humanity before the face of the boundless cosmos in his works. And now we come to the main question of our video: what if our universe can fit on the tip of a needle? Suddenly, the solar system and you are just one of the myriads of similar entities that make up some other matter. Rejecting this version is illogical, so we can assume that the same is true for the particles that make up our existence. It turns out that, as one wise man said, infinity is truly limitless. This means that our reality could really be on a subatomic level of a completely different reality. Similarly, entire worlds could also be located on our subatomic level, and so on to infinity in both directions of scale, which sounds incredible, but exploring the incredible is our job. The most interesting thing is that by looking at the universe we know and observing the laws that function within it, we can easily come to the same conclusion: everything begins with the smallest particles like atoms and ends with colossal celestial bodies and entire clusters of stars, starting with your lunch today and ending with a recently discovered exoplanet. Everything consists of the same building material. Finding the theory of everything, which relates the micro and macro worlds, is the dream of the scientific community. Combining quantum mechanics and classical physics, young scientists may be able to understand the true nature of our universe, even beyond its boundaries. According to one of the most popular versions of the origin of our universe, it began as an infinitely dense and yet small singularity, which then expanded to all known limits. This is called the Big Bang Theory, from something small to something very big. It also seems to correlate quite well with what we talked about today, micro and macrocosmos, but there is an important remark. It's not that it originated from one atom. There was a singularity that gave birth to the Big Bang. Despite its small size, it contained everything necessary for building the entire universe, but calling it the origin from one atom is not accurate. There is also the so-called string theory, an excellent candidate for the theory of everything. The basic idea is incredibly complex and has many interpretations. The theory suggests that the singularity is not a spherical object whose shape and appearance we remember from school, but rather strings or something very similar to them. The relationship between these vibrating strings includes almost all known laws of classical physics, including gravity and quantum mechanics. However, the string theory also has its weaknesses. Although it explains a lot, it begins to stumble when it comes to dark matter, where the string theory starts to sag. But scientists have been working on incorporating it into the theory. In late 2018, Swedish scientists published a new version of the string theory, which suggests that our universe exists on the border of a constantly expanding bubble. This version rejects the familiar 4 dimensions of 3 spatial and 1 temporal and suggests that our entire universe is just vibrations on the surface of this bubble. What happens inside the bubble or at a distance from it remains a mystery. How do you feel about these perspectives? We are just a small civilization and a tiny piece of reality located on the surface of the bubble, which itself could be a part of something much larger. Perhaps our entire world is just a proton or a quark, just a small particle of reality. Why don't we feel it? Does it feel like the components in your sunglasses, which are just plastic? But is it really important to get a definitive answer to this question? Ultimately, we should just be grateful that our vast and shared home called the universe is full of such amazing mysteries. Getting to know these mysteries is our task, and we hope you enjoyed our video. Write your thoughts in the comments. Don't forget to like and subscribe to the channel for more content. What would happen if there were a black hole in our solar system? This is the topic we will explore, especially from the perspective of Earth's satellites. Mass, concept, and numbers. First, let's clarify the concept and numbers a little. Known black holes are formed by a vast amount of matter collapsing into a small space, most often from a star, including very massive stars. The typical mass of a black hole that astronomers have been able to detect is at least 3 to 5 times that of the Sun. Of course, if there were such a black hole where we could stand, we wouldn't be orbiting around the Earth. Instead, the Earth would become its satellite, orbiting around it. But in theory, any amount of matter could be compressed into a singularity, creating a black hole. Therefore, for the purposes of this video, we will assume that our hypothetical black hole has a mass similar to that of the Moon. How could such an object come into being? It could be born from some anomaly, or it could have been born for an alien experiment. More accurately speaking, the event horizon of a black hole is very small, about 0.1 millimeters in size. Earth is not sucked into it because black holes behave the same as celestial bodies with the same mass. However, its effect on Earth is very interesting. To talk about the effect of such a black hole on Earth, it's best to start with something simple. For example, let's start with the appearance of the night sky. A black hole with stellar mass would have a bright accretion disk surrounding the black sphere, creating a very beautiful spectacle. You might have seen this kind of image in an illustration, science fiction movie, or computer game, but please forget about the image this time, as it doesn't apply in the case we are discussing, as I mentioned earlier. Black holes with masses similar to the Moon are very small. They have a strong gravitational force, but they are so small that at best, we can only see faint patches in the sky on a regular basis. In the worst case, it may not be until the space age that we realize the existence of black holes. Instead of solar eclipses, we may observe the Sun through a gravitational lens caused by a black hole. Light passing through the side of a black hole is distorted by its gravity. Therefore, when the Moon passes between the Sun and the Earth, we can briefly observe a faint distortion on the solar disk. Also, when the moon is between a star and the Earth, the star that is the source of light appears differently to us due to the lens effect, such as appearing to emit momentary flashes like some other stars, or appearing to expand slightly. However, because black holes are so small, we can observe these phenomena only through high-performance telescopes. There is a deep connection between our culture and the moon, historically. The first calendar was likely the lunar calendar, no matter when it was made. The periodic changes in the size of the moon can be easily observed if there is only 1 month, but it is difficult to calculate it in areas where there are only rainy and dry seasons. If the moon were to become a black hole, the spirits would naturally become unknowable. This would cause a significant delay in the development of not only astronomy but also civilization as a whole. In reality, time would only be measured in day and night, and it wasn't until the Stone Age that the concept of a year could be recognized. However, this is a story of when the Earth could somehow escape the destructive effects of a black hole, which may be quite difficult. As I mentioned before, this is the story of the eternal end. When a black hole appears nearby, it is very small compared to the many major changes that occur. It also affects the Earth's gravity, not just cars, but also constantly swirling to prevent other parts of the Earth from cooling down. Even if there is a black hole instead of the moon, there will still be tidal effects on the Earth, but because of its small size, the tidal effect appears to be concentrated in a narrower range and at a pinpoint. However, it will act more strongly. Near the equator of the Earth, natural disasters such as volcanic eruptions or earthquakes will occur intermittently. As a result, life will become practically impossible, and there will be a significant impact on the Earth's climate. Due to this geological activity, the Earth is getting warmer, and the transparency of the air is decreasing due to the continuous emission of volcanic ash. Earth will become darker and hotter in such an environment. Before we even consider whether humans can be born in such a scenario, it is unknown whether life can survive at all. It is entirely possible for Earth to become like Venus. Another problem is radiation emitted from the Earth's satellites. Black holes, in particular, emit severe radiation from their accretion disks. In this case, interaction with solar winds and the moon's magnetic field may also occur. Perhaps the Earth will be bombarded with constant streams of various particles, and it is unknown whether the Earth's magnetic field can protect it. If it cannot, after hundreds of millions of years of radiation exposure, all of the Earth's water will decompose due to the radiation's influence. Without radiation protection suits, the Earth will become an endless barren wasteland where nothing can survive. Of course, in such a scenario, no form of life could exist. Finally, there is a phenomenon called Hawking radiation, which suggests that any black hole will consume energy and mass over time and eventually evaporate. Particle pairs are created and evaporate, which is a very gradual process. For a stellar mass black hole, it would take endless time with dozens or hundreds of pairs sticking together, while a black hole with the mass of the moon would take only billions or trillions of years. In theory, the smaller the mass of a black hole, the more actively the particles mentioned earlier are created, causing another problem for us. As the particles rain down on Earth, they create confusion in the magnetic field and cause geomagnetic storms one after another until the last one explodes and dies. Of course, that is if it hasn't been swallowed by another black hole by then. There is also a theory that there are many small black holes in the universe, which are considered as one of the candidates for the role of mysterious dark matter. These black holes are thought to have emerged after the Big Bang because they have certain properties that satisfy the matter and space. If this hypothesis is correct, theoretically, it is also possible for Earth to have such a satellite. Lastly, there is something I would like to say. The possibility of such satellites being born in the solar system is low. In such cases, black holes will swallow all matter in the gas and dust cloud phase and grow to become a normal-massed black hole. However, there is a good chance that they may come from somewhere in a completed star system, far away. Certainly, there has never been a similar phenomenon observed in an alien planet. Therefore, the possibility of such an event occurring seems low. If this video was helpful, please hit the like button, which is the greatest strength and motivation for us. Andromeda Galaxy is perhaps the most well-known galaxy to the general public, excluding the galaxy we live in. This galaxy is frequently featured in science fiction works more than any other galaxy. This is not surprising because it is the largest galaxy closest to Earth. It takes about 2.5 million light-years to reach the Andromeda Galaxy, which is a surprising number for us, but a trivial distance in terms of the universe. The Andromeda Galaxy is one of the few galaxies visible to the naked eye. Therefore, its existence has been known for a long time. However, its structure cannot be seen due to the fact that it is very far away. Therefore, in medieval literature, it was depicted as a small cloud floating in the night sky. Even with the invention of telescopes, this problem could not be solved. Early telescopes were very primitive, so individual stars in the Andromeda Galaxy could not be distinguished. Some nebulae were discovered in the Milky Way, and the protagonist of this video was also considered one of those nebulae. The original name given to this galaxy was the Andromeda Nebula, due to such circumstances. In 1855, scientists noticed an explosion that occurred in the Andromeda Galaxy. It was probably a very bright supernova, but it was considered simply a new star starting to burn. The fact that a star begins to burn inside a cradle of stars, known as a nebula, was already known at that time. Therefore, this distant galaxy is constantly expanding. The misconception that common nebulae are impossible to understand seems to be deepening. It was only towards the end of the 19th century, when the telescope had been improved, that we were able to barely recognize the structures of whirlpool arms in the Andromeda Galaxy and bright nebulae. This was also around the time when a faint voice first suggested that what we were building was not a nebula, but another galaxy, like the Milky Way. However, at the time, the single galaxy model was dominant, and most scientists thought that the Milky Way was the entire universe. It should be noted that in the mid-19th century, there was a claim that the Magellanic Clouds were other galaxies, but many people denied it for the same reasons. To defend the scientists of the time, their reaction was not simply due to rigid thinking. At the time, astronomers did not have the ability to measure distances to distant celestial bodies as accurately as we do now. For example, in the case of the Andromeda Galaxy, various researchers estimated the distance to be closer to Polaris than the North Pole. Finally, in 1923, the great Edwin Hubble succeeded in using the latest telescope of the time to discover several Cepheid variables in the Andromeda Galaxy. Cepheid variables are a type of bright yellow variable star that has the characteristic of always changing its brightness with the same period, even though it is the same star. There is a formula for deriving the distance to a star by substituting the apparent brightness and actual brightness of the star. Cepheid variables are the easiest type of variable star to improve. When Hubble improved the distance to the Cepheid variables in the Andromeda Galaxy, he realized that it couldn't exist in the Galaxy 1 group. Even the boldest of the past calculations turned out to be wrong. The distance was over 2.5 million light-years. As a result, the scale of the universe known to humankind expanded enormously. Other celestial bodies, such as the Magellanic Clouds, were also confirmed to exist beyond our galaxy by Hubble. Andromeda Galaxy was the first to be identified as a galaxy. As research progressed, we learned many new and interesting facts about the Andromeda Galaxy. For example, we learned that this galaxy is much larger than our own Milky Way, with a diameter of over 45,000 parsecs and containing at least first-magnitude stars. The largest galaxy in our local group is the Andromeda Galaxy, followed by the Milky Way. Like the galaxy, Andromeda has a distinct disk and several spiral arms. Most of the countless stars that belong to the Andromeda Galaxy are included in this disk. The center of the galaxy contains the galactic nucleus. Interestingly, the galactic nucleus appears to be double. Even in photographs, two distinct structures, one large and one small, separated by about 5 light-years, can be clearly identified. The structure on the dimmer side is called P2, and it is believed to be the true center of the Andromeda Galaxy. There is a supermassive black hole at this location, but its mass has not yet been fully determined. Estimates suggest that it may be tens of millions or even billions of times more massive than the Sun. For reference, the supermassive black hole at the center of our own Milky Way galaxy has a mass of only about 4.3 million suns. The larger and brighter structure, located slightly away from the center of the galaxy, is called P1. However, it is currently unclear what this structure is. Perhaps, from an astronomical perspective, relatively recently, the Andromeda Galaxy may have consumed another galaxy, and that galaxy has not yet been completely digested. If that is the case, P1 may be the remnant of the disrupted galaxy. Even those who have never heard of it before may not know that galaxies sometimes swallow other galaxies. Andromeda is particularly interesting in this regard, as one of the highlights is the globular cluster called Mayall-2, which is located 130,000 light-years away from the galaxy's center. Mayall-2, discovered in 1953, is known as the brightest star cluster in our local galaxy group. Usually, globular clusters are composed of very old, dim stars that were born at a similar time. However, Mayall-2 is more interesting because it contains a variety of age groups of stars, including some that are much younger. Stars with a high metal content also exist. There probably isn't any life in the May star cluster. In the globular cluster, stars are always in planetary system shapes because they are densely packed. Nevertheless, rare shapes are clearly visible in the Andromeda Galaxy that are smaller than formal galaxies, including dwarf galaxies. These structures have a spherical shape, a very large radius, and contain a large number of stars. Perhaps, like Mayway 2, they are remnants of swallowed galaxies. In 1999, scientists recorded an anomalous phenomenon called PA99 in the Andromeda Galaxy. During this process, the fusion of an old red giant star, one of the observed low-mass celestial bodies, was caused. There are several interpretations for this phenomenon. Some scientists believe that this mysterious celestial body could be a planet with a mass of about 6 times that of Jupiter. If their view is correct, this would be the first extraterrestrial planet discovered in another galaxy. However, other astronomers argue that the object involved in this phenomenon is not a planet, but a small star. In any case, there will be many planets in the Andromeda Galaxy, including those similar to Earth. In this galaxy, there are very old stars and very young stars, and the stars are clearly divided into 3 generations, accounting for most of the population of the galaxy when combined. Scientists paid attention to this point immediately. The age of these stars ranges from 10 billion to 11 billion years, respectively. Of course, what we are most interested in is the second star that corresponds to the Sun. There are enough of such stars remaining in the Andromeda Galaxy, so surely many extraterrestrials will be discovered. If there are any intelligent beings or humans that still exist in the Andromeda Galaxy in tens of billions of years, they may come to meet us without even having to show off their technological skills. However, the problem is that the two galaxies are slowly approaching each other and will collide and merge 4 billion years from now to become one galaxy. But there won't be any major cataclysms on the scale of the Earth. The distance between the stars is quite wide, and even if aliens interfere between us and Proxima Centauri, there won't be any significant harm. Please subscribe to our channel and press like, and don't forget to share this video on social media. Space is a place of frighteningly vast distances. Just the thought that incredibly fast light takes 13 billion years to reach us from some galaxy can make one feel uneasy. But if we focus on the positive, the distance between us and Mars, just a dozen or so light minutes away, seems like a hop in space terms. And there are times when our cosmic neighbors seem incredibly close. Even the 4 light years to Alpha Centauri don't look scary compared to distant galaxies. It's insanely close, and there's no doubt that humanity will eventually reach our solar system's cosmic neighbors. But who are they, apart from Alpha Centauri? Few would name the stars neighboring our Sun, but don't worry, we'll cover that in the next couple of minutes, and also estimate how far away they are. Before we talk about the chances of finding life on our cosmic neighbors, let's first discuss how scientists can determine which stars in the sky are close to us and which are far away, and how they can be sure they're not mistaken. The concept of a parsec, which you've probably heard of from science fiction, is a unit of measurement that was introduced thanks to the use of parallax. The prefix par means parallel, and SEC stands for sector of gas, which is, of course, a joke. The actual meaning of acer is arcsecond, thanks to which we can use Apple devices to experience parallax in a simplified way. In fact, with the release of the iPhone 7, Apple introduced a new type of wallpaper that creates the illusion of depth when the phone is moved, simulating the effect of parallax. The term symbolizes the change in the apparent position of an object depending on the position of the observer. Try holding up your finger and closing your left eye while looking at it with your right eye. Then, quickly close your right eye and open your left eye. You should see your finger appear to jump to the side. This is the same principle that scientists use to measure the distance to nearby stars. If you move your finger closer to your eyes and repeat the procedure, you will see that it has shifted more than before. If you draw imaginary lines to your finger, you will get a triangle, one side of which you know well the distance between your eyes. The two angles at which the eyes are looking at the finger are also known, and finding the length of the remaining side, which will be the distance to the finger, is a matter of time. And now, put reason and great scientists, whole generations of hard work and huge formulas on this scheme, and you will get a method according to which the distance to the objects was calculated with excellent accuracy. Distances to thousands of stars, and even to the planets of our solar system, as well as the Sun itself, were initially determined using the parallax method. This method is based on observing how their position changes against more distant objects when viewed from different points or as the Earth rotates. It is not difficult to guess that objects that are too far away cannot be calculated using the parallax method, since we are limited by the diameter of the Earth. Even when viewed from both ends of the planet or during a complete rotation, the displacement of distant stars will be negligible. Other methods are used for those objects. But what we are interested in are the nearest neighbors of the solar system, which can be reached by simple parallax and later refined using more accurate methods. It should be noted that even 10 light years is a huge distance. The distance is too great for us to judge the number of neighboring stars definitively. In order to determine the distance to something, you need to see it first, and among the stars, there are very dim brown dwarfs. Therefore, the question of a precise number of our nearest neighbors remains open at the moment. With brown dwarfs taken into account, it is estimated that there are 14 large neighboring stars at a distance of 10 light years from our solar system. Let's start our story with a tiny red dwarf, standing at a height of 154. If we were to send light directly towards it, it would take about 9 69/100 years to reach it, which is amazing. At least we know that this star is still alive, unlike some fairy dish that sent its light to us about 6,000 years ago. We see it as it was when the ancient Egyptians were building the Pyramid of Cheops, so what can we say about row 154? Not much. It's a very typical star, as red dwarfs make up more than half of the stars in the galaxy. Row 154 is 5 times smaller than the Sun in mass and 300 times dimmer in brightness, and is located in the constellation Sagittarius. Despite its proximity to Earth, it cannot be seen with the naked eye. Interestingly, 154 is characterized by intense X-ray radiation, which is greater than that of the Sun. This can be explained by the star's relative youth, as it is less than 1 billion years old. At the time of its formation, there were already algae on Earth. However, due to its proximity to the Sun, the star falls into the first category of astronomers' attention. Searching for planets around stars is incredibly difficult because they are very dim compared to stars, and 154's height itself is not particularly bright, plus it is close. At one point, one of NASA's missions was very interested in studying this star because theoretically, we could find a planet there that is 3 times the size of Earth. However, unfortunately, funding was not obtained and there wasn't much reason for the planet, which would need to have Earth-like conditions, to be located 4 times closer to its star than Mercury is to the Sun. Its orbit would be blocked, and the hypothetical Earth-like planet around 154 would always be facing one side, receiving too much X-ray radiation and too little red light for photosynthesis. Therefore, even theoretically, finding habitable planets around red dwarfs like 154 is extremely challenging. We don't really have anything to do with our lives, but our theories are still based on the Earth, so let's talk about Sirius instead. You don't need to get to know it twice, it's the brightest star in the night sky. If you put the Sun and Sirius at the same distance, Sirius will be 25 times brighter than our star. However, we shouldn't be deceived, there are much brighter stars in space in absolute terms than Sirius. For example, Rigel's luminosity is about 120,000 times higher than the Sun's. If you were to switch places between Rigel and Sirius in the night sky, Rigel would shine like a third of the moon. Nevertheless, Sirius is still a bright star. It is roughly twice as heavy as the Sun and almost twice as large as the Earth, so it has been known to humans since ancient times. It was worshipped in ancient Egypt, Babylon, and Greece, and that's where it all started. The name Sirius, which translates as shining, also refers to its location in the constellation Canis Major. According to legend, Sirius is the dog of Orion. The Romans even translated the star's name as Canicula, meaning little dog, because its morning visibility coincided with hot days, which later became known as dog days thanks to the star. Now, the word vacation is associated with the meaning of the word canicula, and school children all over the planet are happy to have it. What is this neighbor, located just 8.5 light years away from us? Sirius is a great star of spectral class A1, and it has a tiny white dwarf companion, Sirius B, which astronomers jokingly call the puppy. This is really the case because Sirius B is 360 times dimmer than the Sun. However, it should be noted that there are much brighter stars in space than Sirius in absolute terms. Puppy is still well-fed, and in terms of mass, it is not inferior to our Sun, being one of the largest white dwarfs. However, this does not make the Sirius system particularly unique. There is every reason to believe that systems with 2 stars are more common in space than single stars, and our introverted Sun is a typical resident of the universe. If there is potential for life in this system from our point of view, then a terrestrial planet and conditions for liquid water would need to be located far from Sirius, as far as Jupiter is from the Sun, which is 4 times farther than the Earth is now. The year would last about 6 years, which is not the worst thing, but the worst is that Sirius emits much more ultraviolet radiation than the Sun. It is possible to forget, and therefore there are questions about ordinary free oxygen, and the weight of the Sirius puppy will also affect the orbit, and therefore the stability of conditions on the planet. In general, everything is very bad, and from the point of view of real research, even worse. Sirius is very bright, and despite its proximity to the Sun, it is very difficult to find a planet near it. Current scientific achievements allow us, in theory, to find only a planet with a mass of 510 Jupiters at a distance of 25 times farther than the Earth from the Sun. In 2008, such a test was conducted, and the result was predictable negative. Some scientists still believe that Sirius is not a binary triple star, and we still cannot conclusively refute them. Hubble tried to find another brown dwarf or some huge Jupiter, but he could not, although the theoretical calculations as a whole allow for the possibility of stable orbits within the system. Perhaps in the near future, we will study Sirius better, as it slowly approaches the Earth, and in the next few tens of thousands of years, it will shine even brighter. However, the distance will increase again, but we can say for sure that for another couple of 100,000 years, Sirius will be the brightest star in the sky, unlike our next neighbors. Wolf 359 is insanely dim red dwarf. It is closer to us than Sirius and is located 7.8 light-years from the Sun, but much dimmer. It is impossible to see a planet with the naked eye in the sky. If we were to switch our Sun to Wolf 359, then Earth's round shape would disappear. Without a telescope, it wouldn't be visible, and during the day it would be 10 times brighter than during a full moon on Wolfie 359. We wouldn't have stopped if it weren't for its high cavity in two directions. The first reason is the potential presence of two exoplanets. In 2019, a team of astronomers led by Meg Kotlamy published a study announcing two candidates for exoplanets in the Wolf 359 system. The planet is 20 to 40 times larger than Earth and rotates twice as far away. The second planet is allegedly only 4 times larger than our planet and is located close to the star, close enough to allow the possibility of life. However, scientists quickly cooled their enthusiasm, as the amount of radiation that this hypothetical planet would receive would be many times greater than Earth's, making the existence of life unlikely. The planets themselves are still only candidates, as direct observation and confirmation of their existence is difficult. But scientists remain interested in Wolf 359 for two reasons. First, this star is located near the plane of the ecliptic, which means that if you were to look at the Sun from the Wolf 359 system, all the planets of the solar system would be visible at once. Hypothetically, if advanced aliens have scattered probes throughout the universe for scanning, then a probe on Wolfie 359 could easily discover the existence of Earth. And, in turn, by observing Wolfie 359, we may find a hypothetical probe studying us. Of course, these searches have not led to anything yet. Much more productive to scientists is the legendary star Barnard, another neighbor of our Sun. It is the second closest object of its type to us, or the fourth if you count Alpha Centauri, which is a triple star system. Firstly, it is important to know how fast Barnard's star is. It approaches us so quickly that it creates the impression that it owed the Sun 100 kilometers. Except for the Sun itself, it is the fastest star in the sky, flying towards us at a speed of 110 kilometers per second. And if now Barnard's star is somewhere 6 light-years away, then in 11,000 years of our era, the distance will be reduced by a third and will already be equal to 3 whole light-years. By cosmic standards, this is insanely fast. We see it as it was at the time when the construction of the Pyramid of Khufu in ancient Egypt had not yet begun. There is not much interesting to say about its height of 154, as it is a very typical star, since red dwarfs make up more than half of the stars in the galaxy. Its height is 5 times smaller than that of the Sun, and its brightness is 300 times less. It is located in the constellation Sagittarius, and, despite its proximity to Earth, it cannot be seen with the naked eye. The only notable thing about its height of 154 is the incredibly intense X-ray radiation it emits, which is more than that of the Sun. This can be explained by the star's relative youth, which is less than 1 billion years old. When it was formed, there were already algae on Earth, but because of its proximity to the Sun, the star is among the brightest in the sky. In addition, it has X-ray radiation and is a bit lazy and slow-moving old guy, but this doesn't negate the fact that the temperature on the surface of this star, belonging to the red dwarf Barnard, is almost 3,000 degrees. It's worth respecting at least because, due to its proximity, it has become almost a standard in studying stars of this type. It's quite difficult to study them because they are dim and heavy, but it's slightly easier to search for planets than it used to be. Peter van de Kamp announced the discovery of 2 planets orbiting Barnard's star in 1960. The first planet was similar in mass to Jupiter, while the second was only half as large. However, Peter couldn't find confirmation of his discovery, even though he tried very hard. The Hubble telescope helped to clarify that planets with a mass greater than 5 Earths cannot orbit Barnard's star. It seemed that there was no hope left, but in 2018, an international team of astronomers announced that they had found a planet about 3 times the size of Earth, orbiting Barnard's star at more than twice the distance that Earth orbits the Sun. However, despite the accuracy of the calculations, Barnard's Planet B still remains a candidate, although its existence was also confirmed in 2021. Furthermore, most astronomers give a 90% chance of potential life on a potential exoplanet. However, even if the planet is twice as close to its star as Earth is to the Sun, it will receive extremely little heat due to the coolness of the star. Sometimes the temperature on a hypothetical exoplanet is unlikely to be higher than -170 degrees. In general, the prospects for life are bleak with the other neighbors of Earth that have potential for life. However, the mighty system of Alpha Centauri, consisting of 3 stars, comes onto the scene, located about 4 light-years away from the Sun. 2 of the 3 stars in Alpha Centauri A and Alpha Centauri B, are of great interest as they are very similar to our Sun. Alpha Centauri A shines 1.5 times brighter and is slightly larger than our Sun, while Alpha Centauri B is slightly smaller than the Sun and shines half as much. The entire Alpha Centauri system is slightly older than the Sun, and visually the 2 large stars merge into one when observed from Earth. This is not surprising since they orbit each other at an average distance of only 24 times the distance between the Earth and the Sun. If the Sun were replaced with another star, in moments of closest approach, the star would be separated by a distance equal to that between the Sun and Saturn. The third member of the star system, Proxima Centauri, is a true runt. It is only 1.5 times larger than Jupiter and is a red dwarf. Even Barnard's star looks like a giant against its background. Proxima Centauri is also actively studied, but it is the 2 older sisters, Alpha Centauri A and B, that really excite scientists. They have been studied extensively, even peering into their atmospheres and finding similarities to the Sun, and conducting some of the most precise calculations of possible planetary and life presence. Many simulations were conducted and they conclusively ruled out the presence of giant planets. This is not surprising since 2 of the 3 stars are so close together, and Jupiter would face a sad fate between their gravitational influence. However, simulations showed that both stars have a so-called habitable zone, which is an orbit where theoretically stable planets with liquid water can exist. Unfortunately, due to the brightness of the stars, even taking into account the insane proximity of the Alpha Centauri system, it is difficult to say anything. In 2012, European astronomers claimed to have found an exoplanet around Alpha Centauri B, but its existence was disproved 3 years later. The situation is slightly better for the larger star, Alpha Centauri A. In February 2021, a candidate exoplanet was found there that is remarkably similar in size and orbit to Earth. It will be verified by the James Webb Telescope, and we still have yet to learn the outcome. However, the true king in this scenario is quite unexpected. In the search for life, the collapse of the Proxima Centauri system is not surprising. On the one hand, as we mentioned before, it is slightly easier to find planets around dim stars. However, the exoplanet discovered there in 2016 is astonishing. It is also almost identical in size to Earth, but its year lasts only 11 days, which means it is much closer to the star. Considering that Proxima Centauri is a dim star, this is an ideal combination of factors. The exoplanet candidate receives 65% of the Earth's warmth, which theoretically opens the doors to the existence of liquid water. However, more recent calculations are less optimistic due to the proximity to the star. Potential Earth 20 receives an indecent amount of radiation, and since Proxima Centauri is a red dwarf, it periodically experiences powerful flares. For example, in 2017, a flare was recorded that, according to scientists' data, would have certainly killed the planet. All your life on a planet, even if one existed, is not so bad. There are several candidates for exoplanets in the Alpha Centauri system, some of which are also in the habitable zone. There is hope that the James Webb Telescope will help confirm or refute this data, but of course, Alpha Centauri is the main candidate for all organizations that aim for interstellar travel. There is, of course, the Project Daedalus, which aimed at the Barnard star, but this is rather an exception because scientists mostly dream about Alpha Centauri, and here dreams come up against harsh reality. Humanity has exactly one spacecraft that shows signs of life outside the solar system, Voyager 1, which was launched in 1977 and was actually designed for 5 years. It miraculously stayed on track and in 2012 entered interstellar space, but even it will not approach another star for 40,000 years, although it is not about Alpha Centauri. Voyager is heading in a different direction, as are the New Horizons and Pioneer 10 spacecraft. Their missions, like Voyager, were mainly focused on the inner part of the solar system. Specifically, nobody has sent anything to other stars yet. However, if Voyager had been turned around at the same speed and sent to Proxima Centauri, it would have reached it in 76,000 years. And mind you, this is one of the fastest spacecrafts in human history. Of course, there is also the Helios 2 probe, which was accelerated using the gravitational pull of the Sun to an indecent speed of 240,000 kilometers per hour. But even with this speed, it would take 19,000 years to travel 4 light years. There was a prototype electromagnetic engine from NASA that went even faster during testing. But even for it, it would take 13,000 years to fly to Proxima Centauri. Nuclear and thermonuclear reactor projects do not help much. They are either too dangerous, too expensive, or too slow. The laser sail technology is considered the most promising in the near future. According to this technology, a sail is deployed around the ship, just like in the old days, and solar radiation accelerates it for greater speed. This sail is pushed by lasers, and according to Robert Frisby's calculations, it could reach Alpha Centauri in 12 years. However, for this to happen, its diameter must be a paltry 320 kilometers, and the useful payload would be a canned food tin and a tennis racket. And there is also antimatter, engines powered by which can be incredibly efficient. However, the production of 1 gram of antimatter would cost several $trillion. Overall, the situation with interstellar travel is very sad. Either the necessary technologies don't exist yet, or they are just concepts, or they are too expensive, considering that interstellar travel has little practical value. It's clear that most scientists are focused on solving everyday problems. The bright spot on this background and hope for our generation is the Dragonfly project, which involves sending a very tiny sailcraft to Alpha Centauri. The goal of the project is to reach the star within 1 generation, but for now, it's just a concept. Strictly speaking, we need to study our own solar system better, and until we finally figure out Mars and potentially habitable moons of Jupiter, looking towards Sirius and Barnard star is premature. As you all know, a black hole is one of the scariest things in the universe. Once you cross the horizon of an event where such a space monster is involved, there is no turning back. But what if we experienced it a long time ago? What if the entire universe was a black hole and we were already inside it? Let's first think about what commonalities there are between the universe and a typical black hole. A black hole is formed when a massive amount of matter contracts to the point where it cannot be seen even with powerful microscopes and collapses. In the case of a stellar mass black hole, the core of an exploded supernova collapses, while in the case of a supermassive black hole, a large cloud of gas and dust or a giant protostar collapses in its entirety, but the principle is the same in either case. The gravity of celestial bodies depends on their density, as you may have learned in physics class. Density can be calculated by dividing mass by volume. Black holes have a massive amount of mass, but have an extremely small volume, so the gravity on their surface is very strong, and even light cannot escape at the speed of light. Matter is condensed into a very small point. Even if one is located at a certain distance from the singularity, the area where gravity is so strong that nothing can escape is called the event horizon. In the images or illustrations of black holes, it is the black sphere-like object. Outside the event horizon, black holes behave like any other celestial body with the same mass, affected by gravity but not absorbing anything. It is like how the sun does not absorb the Earth. This means that there could be normal planets capable of escaping near black holes. However, what we are more interested in now is the interior of a black hole. Of course, we cannot directly investigate the interior of a black hole. Furthermore, if we cross the event horizon, we cannot stop or turn back as time almost stops due to the strong gravity, and space itself loses the property of time. Similarly, within a black hole, space cannot be reversed. Once you cross the event horizon, you have no chance to stop or return and can only fall towards the singularity. In fact, the fact that it cannot be crossed is the biggest common point between the universe and a black hole. Among the phenomena occurring in the universe, there are a few that can only be explained by the influence of the gravity of another universe. The substance of one universe cannot move to another universe. The substance of the universe is not contracted into a very small volume, but the opposite is true. However, in reality, singularities and black holes do not have a uniform shape, unlike abstract mathematical black holes. In the case of a rotating black hole, the singularity has a ring-like shape. Although it is very small, it is not zero in size. Anyway, size is a relative thing, so to speak. For humans, viruses are extremely small existences, but conversely, for viruses, humans are extremely large existences. Of course, it is possible to argue that we are not moving towards the singularity in the universe. However, if all the material in the universe has already collapsed into a singularity, isn't it just that there is no place to move? Through these hypotheses and fine-tuning, scientists have come to think that the universe may not be a giant black hole. This concept is called the Schwarzschild's Little Universe or Black Hole Universe, and it was first revived by Indian scientist R. N. Iyengar and British astrophysicist A. G. S. Venturini in 1972. There are also interesting theories about black hole universe proposed by modern famous physicists, such as the one by Lee Smolin. He faced the fine-tuning problem of the universe, which troubles many scientists. Our universe exists thanks to the existence of many constants. For example, if one constant had changed slightly, there might not have been heavier elements than boron, and stars might not have formed. Life itself, including intelligent life, might have been impossible. Additionally, in the multiverse theory, it is believed that there are countless universes, each with its own independent fundamental physical constants. However, in our universe, physical constants happen to be suitable for the birth of life by chance. This is similar to the idea that only Earth among the celestial bodies in the solar system has the conditions for the birth of life. Smolin developed this hypothesis further. He expected that the universe was repeatedly multiplying through the power of black holes. Every time a black hole is born, it has its own unique physical constants, different from those of our universe. He believes that a new universe has been born. According to Smolin, the constants necessary for the birth of life are also necessary for the occurrence of black holes in the universe, and as the number of black holes increases, the offspring produced by the universe also increases. If it is confirmed that we are living inside a black hole, it would be strong evidence in support of Smolin's theory. However, we cannot directly confirm whether the universe we observe from outside is actually shaped like a black hole. Therefore, to determine whether the Schwarzschild spacetime is correct or not, we must rely on indirect evidence. In the scientific community, there are concepts such as the Schwarzschild radius or the counterattack against the Schwarzschild spacetime regarding black holes. These concepts are based on the mass of the black hole. The term event horizon radius refers to the radius of the horizon of an event. For example, if calculated by the mass of the Earth, this value would be less than 1 centimeter. This means that if all the matter on Earth were to collapse into a singularity, the radius of the event horizon would be this value, indicating the birth of a black hole. In addition, if the Sun were to collapse, a black hole with a radius of 3 kilometers would be formed. Various calculations have shown that if all the mass in the observable universe were to collapse, the Schwarzschild radius would be between 10 and 13 billion light-years. If the black hole hypothesis is correct, the Hubble radius would also be almost the same. The Hubble sphere refers to the virtual sphere that expands around an observer, and beyond this range, all objects are no longer visible because they move away from the observer at a speed faster than the speed of light due to the expansion of the universe. The radius of the Hubble sphere is 14.4 billion light-years. In other words, the Hubble sphere is larger than the Schwarzschild radius of the observable universe. There are researchers who support this idea, while there are also researchers who claim that the concept of the Schwarzschild radius is fundamentally flawed. They point out that there are other issues with this model and the related Smoluchowski hypothesis. For example, a black hole is not a physical object in itself. Like other celestial bodies, something is always pouring into it, mostly gas or dust from space. As this material falls into the black hole, its mass increases, although the increase is negligible. On the other hand, we do not see any evidence of stable matter supply from somewhere in our universe. Also, black holes regularly collide with other planets, stars, or other black holes, which is a very rare phenomenon, but it does happen. Our universe may have experienced similar collisions over billions of years, but there is no concrete evidence of such collisions happening. The existence of whether we are actually inside a black hole or not is still a matter of debate and has not been confirmed at this time. But as ordinary humans, all we can do is turn our eyes to space in pursuit of new discoveries. Even if we knew whether the universe is a black hole or not, the fact that the universe is beautiful and magnificent would not change. Please subscribe to our channel and hit the like button, and don't forget to share the video on your social media. You may have heard that the Sun is an incredibly large celestial body compared to the Earth, but there are even larger stars beyond that difference. The biggest of the biggest. What I'm going to introduce now is a star named Stephenson 2-18. This star is located in the same constellation as the number 1 star that had reigned in the past in the constellation of the Shield. The Shield star was considered the biggest star ever, but later it was determined that Stephenson was even bigger. This star is the first part of the binary system Stephenson 2, and it is located about 18,900 light-years away from Earth. It has rewritten a few records not long after its discovery. As you may already know, Stephenson 2-18 is the biggest star that humans could imagine. If we placed this star in the position of our Sun, even Saturn's orbit would be within the star. 5 planets including Earth, which is closer to the Sun than Saturn, would be swallowed by this giant star. In addition, Stephenson 2-18 is also one of the brightest stars in our galaxy. According to IAU standards, its brightness is even 440,000 times that of our Sun, depending on the calculation. However, there are times when it shows a more modest figure of only 98,000 times brighter than the Sun. Nevertheless, it is still an unusually bright star. If the Sun shone as brightly as this star, not only would we be unable to see anything, but the Earth would have been completely incinerated. Thanks to its abnormal luminosity, Stephenson 2-18 is visible even beyond the galaxy. If there were a civilization that developed somewhere in the Andromeda Galaxy, Stephenson 2-18 might have been one of the first stars discovered by extraterrestrial beings using telescopes. This star is exceptionally cool in this category, classified as M6.0 on the spectral type. Its temperature is not even close to that of an advertising light at 3,200 Kelvin. Typically, stars classified as red supergiants are hotter and are known to have temperatures of at least 3,500 Kelvin. Originally, this star is also extremely rare. It is not a very high rating for a red supergiant. Moreover, this star is too bright compared to its rating, and conversely, its temperature is too low. Of course, it cannot be denied that there might be a possibility that scientists made some miscalculations somewhere. However, if there were no errors in the calculations, this peculiar star will throw a big shockwave to the current scientific models, especially to the models related to the evolution of stars. What does this giant star reflect? When talking about various rare stars, the public raises one question: can life exist in that stellar system? However, for today's protagonist, there is nothing special to discuss as no planet has been discovered yet. However, we cannot assert that there are no planets simply because we have not found any. Therefore, let's imagine what kind of planets could exist around this star and what possibilities there are. First of all, Stephenson 2-18 was not originally in its present state. We need to keep in mind that from birth, there are no red supergiant stars. Stars become red supergiants as they age, including our Sun, which will follow the same fate, although it won't become as massive as others. We don't know what kind of genius this star was before becoming a red supergiant, but it was probably a massive star with a similar spectrum to our Sun, and it would have remained in that state for billions of years, providing enough time for life to emerge on planets in its system. At that time, this star was not particularly large, at most 2 to 3 times the size of the Sun. Although it was not as bright as other stars, considering other characteristics, it would have had a relatively large and bright habitable zone. There may have been more than one planet within the habitable zone. In other words, there is a good chance that life existed in the Stephenson 2-18 system. There is a possibility that there are multiple planets with such conditions. In that case, what are the chances of discovering intelligent life by discovering a way to travel between stars and visiting the present time? Unfortunately, the probability of that happening is low. When this star began to expand and take on its current form, the planets inside the heavy-tailed zone would have been swallowed up. In addition, the brightness of this star has been increasing since long before that, causing the planet's surface to turn into a sea of lava. In other words, even if the planet itself still exists, all Earth-like life forms will have perished. However, there may be sharp viewers who raise a question here. As the star expands and becomes brighter, wouldn't the heavy-tailed zone widen? Moreover, even if a planet near the primary star was destroyed, couldn't a celestial body that was far away until now become one instead? When the binary system was young, the farthest edge of the star system was trapped in a hellish cold similar to Pluto in the solar system. However, after the star became a blue giant, the temperature rose and it became warmer. If there was sufficient gravity, there might have been the possibility of liquid water or atmosphere appearing there. However, there is one problem. The star's blue giant phase is an extremely short period in astronomical terms. It might be enough time for life to be born, but it would not evolve. Additionally, if there were planets in distant regions that had deep oceans under an ice cap like Europa and life existed there, it would be destroyed due to global warming. The ice cap would melt, and the oceans would become vulnerable to radiation from space. In other words, if there were organisms including intelligent life on Stephenson 2-18, they would not survive. Even if it existed, it seems that it perished a long time ago. At best, we can only assume that an intelligent life form moved to another star system with a longer lifespan. As I mentioned before, the fate of a star in its red supergiant phase is very short. As the star expands, it can no longer maintain the outermost layer of gas due to its gravity, and the gas is scattered into space. As the star's mass decreases, so does its gravity, which means it cannot retain a lot of material. The star cannot stop melting away, and eventually, it will become a white dwarf, leaving only its core. That's all for today's video. Thank you for watching until the end. I hope you enjoyed the video. To summarize, we are living in a perfect time to observe rare stars like Stephenson 2-18. By studying this star, we have learned a lot about the fate of other stars, including our own Sun. Unfortunately, with our current technology, we cannot send a probe to explore this star, but we can still enjoy many other interesting events in space, including aliens. Please subscribe not to miss any of these interesting issues, and don't forget to like and share this video on your social media. We are also waiting for your comments on this video.
In many ways, black holes are the most extreme objects in the universe. They literally pack a huge mass into a smaller volume of space, bending the fabric of space so much that once anything enters a certain area, it can never escape, even if it moves at the ultimate cosmic speed, the speed of light. Apparently, trillions of black holes are distributed in each galaxy of the universe, like our Milky Way, and the largest of them reach billions of solar masses. And yet, if we think about how all these black holes were formed, we can confidently say that each of them was originally made of ordinary matter. None of them were formed from dark matter, even though dark matter exceeds ordinary matter in the universe by a ratio of 5 to 1. But if black holes are the result of gravitational force, and if dark matter responds to it, then what prevents the formation of a black hole from dark matter? Today we have a space story about whether black holes can consist of dark matter. In our modern universe, there are only a few known ways of creating black holes. Perhaps the most common method is the collapse of the core of an extremely massive star. The only thing that prevents a star from collapsing under its own gravity is the energy produced by nuclear fusion in its core, where external radiation pressure balances the internal gravitational force. When the fuel that a star burns runs out, the radiation pressure begins to drop, and the star's core begins to shrink under the influence of its own gravity. As the core shrinks, it heats up to a temperature that is difficult for an ordinary observer to imagine, and the higher the temperature, the greater the chances that the core can start burning even heavier elements, using them as fuel. After these elements are exhausted, the core will collapse as a result of a Type II supernova. If it is massive enough, a black hole will form due to the accumulation of an enormous mass in such a tiny volume of space. If the core is not massive enough, a neutron star will be born. In addition, a black hole can also form as a result of the collision of two neutron stars, provided that the total mass after the merger exceeds a certain threshold. Finally, a black hole can form as a result of direct collapse, when, for example, a single massive star simply becomes too dense for light to escape from a certain volume of space. Once this condition is met, an event horizon will form, and anything that crosses it is guaranteed not only to never escape, but also to quickly increase the mass, and therefore the size, of the forming black hole. In a short amount of time, it can consume all the mass of any object from which it was formed, and then another black hole will appear. Other exotic ways of forming black holes can certainly exist, but it is believed that the above methods are responsible for the overwhelming majority of existing black holes in the observable universe. As you may have noticed, all of these methods have something in common. They are based on ordinary matter consisting of atoms and their components. This becomes even more amazing when you consider a number of facts. Ordinary matter makes up only 1/6 of the total mass of the universe, while dark matter makes up the remaining 5/6, and both normal and dark matter experience gravitational force equally, following the laws of gravity of both Newton and Einstein. In any medium where there is an abundant amount of normal matter, such as in a galaxy like the Milky Way. In general, there is significantly more dark matter in the Milky Way than normal matter, with a ratio of at least 5 to 1. But then why can ordinary matter so effectively form black holes, while dark matter cannot? The key lies not in the force of gravity, but in other forces. Things like friction and collisions that depend on electromagnetic interaction affect ordinary matter, but not dark matter. When a galaxy forms, dark and ordinary matter typically form in a ratio of 5 to 1. This happens on average throughout the cosmos, and all particles subject to gravity are attracted toward the center of the gravitational potential, accelerating in that direction. Here's where it gets interesting. When dark matter passes through a galaxy, it experiences no friction or heating, and there is no opportunity to exchange energy or momentum with other existing particles within the galaxy. As a result, it remains on a slow orbit with high angular momentum, and it may take about 1 billion years to form a complete ellipse. In contrast, ordinary matter has everything dark matter lacks. It collides with other matter, dissipating energy, and as a result, it can settle into a disk shape more quickly than dark matter. An orbit with a large angular momentum may take about 1 billion years to form a complete single ellipse. Ordinary matter, on the other hand, has everything that dark matter lacks. It collides with other particles of baryonic matter, which can exchange energy and momentum. Particles can collide, resulting in losses of kinetic energy and angular momentum. They experience friction and heat up when interacting with other particles of ordinary matter and respond to radiation. Taken together, all of these phenomena lead to a significant difference that can be summarized as follows. Ordinary matter loses angular momentum and moves down to the nucleus of the galaxy, while dark matter always remains diffusely distributed in a vast space, creating a halo around the galaxy. Dark matter can never even approach the density necessary to create an event horizon, and therefore there are no black holes made of dark matter. There are no regions that ever collected enough dark matter to attract light back into them. And this means that there is no dark matter subject to direct collapse, and there are no stellar remnants or other relatively dense objects made of dark matter. Consequently, there is no way for collisions between dark matter-rich objects to form black holes. All the mechanisms by which ordinary matter can collapse into a black hole do not apply to dark matter. Now it becomes clear that when a black hole is formed from ordinary matter, dark matter particles cannot cross the event horizon and increase the mass of the already existing black holes. In terms of dark matter, it is no different from any other form of matter or radiation. When crossing the event horizon, everything inevitably falls into the central singularity and ultimately increases the total mass of the black hole. However, due to the clumpy nature of ordinary matter and the diffuse nature of dark matter, there are no realistic scenarios in which even 1% of the total mass of a black hole could be obtained from dark matter. In fact, based on our current understanding of the universe, there is only one possibility for ever creating a black hole from dark matter. This would occur only if the very early universe had fluctuations of a sufficiently large magnitude that would quickly collapse and form a black hole long before the formation of any stars. If this were to happen, it could create one or several primary black holes that would exist independently of stars. This is the case where only mass matters, since the calculation is based solely on the physics of gravity. It allows us to determine how large the excess density needed to form a primary black hole independent of the mean density is. If the universe is born with an area that is locally 68% larger than the given mean density, it will lead to gravitational collapse and the formation of a primary black hole. And now we have a universe that was born with a spectrum of fluctuations, and these fluctuations gave rise to structures that we see everywhere in the universe. We see the consequences of these fluctuations in temperature defects in the cosmic microwave background. The signature of the cosmic microwave background in features such as correlation functions and the power spectrum of the large-scale structure of the universe. When it comes to scientific conclusions, it is important to ask the right questions and not succumb to the temptation of mistaking what we want for reality, instead of asking if it can be imagined. The temptation to mistake what we desire for reality, instead of asking whether a scenario can be imagined that would circumvent current constraints, which would at best give us a possibility, must be resisted. To ascertain whether a claim is true, we must examine the evidence and ask minimal additional assumptions what the universe tells us about itself. This crucial question of what is true lies at the heart of all science. From a scientific point of view, it is irresponsible to draw conclusions about the truth of a hypothesis without evidence in its favor. When it comes to dark matter, which we understand as it stands, we can expect that there are no black holes today or ever consisting mainly or exclusively of dark matter, and there are no stars, supernova remnants, or scenarios of direct collapse that should have led to a black hole consisting of this matter, and there is no way for this matter to be dense enough to form a black hole after the universe began its existence. Unless we turn to a new but unobserved physics to cause the creation of a certain spectrum of primary black holes composed of dark matter, we can confidently say that it is ordinary matter, not dark matter, that is responsible for the black holes we observe today in our beloved universe. Don't forget to give this video a thumbs up and subscribe to the channel if you haven't already. See you in the next interesting encounter. Many of you are well aware that the largest planet in our solar system has a vast array of satellites, each of which can be intriguing for research purposes. Among all of Jupiter's satellites, the so-called Galilean satellites, Ganymede, Callisto, Europa, and Io are considered the most prominent and well-known. They were discovered in 1610 by the renowned astronomers of the Middle Ages, Galileo Galilei. In this video, we will acquaint ourselves with these famous satellites. Ganymede is the largest satellite not only of Jupiter, but also in the entire solar system. In terms of size, it is 8% larger than Mercury, although it is slightly less massive. In June 2021, a research mission took place within 1,000 kilometers of Ganymede, and scientists are still deciphering what this encounter can tell us about this peculiar world. 2 previous missions captured images of Ganymede, the largest satellite in the solar system. These were the Voyager 1 mission in 1979 and the Galileo spacecraft in the mid-1990s. However, some of these images were taken from less than ideal angles, leaving large white spots about which scientists had no information. Technologies have significantly improved since the launch of those missions. Therefore, scientists were thrilled when the Jupiter explorer Juno revealed a cratered surface of Ganymede in exquisite detail and observed shimmering polar auroras extending between Ganymede's poles and equator. These images unveiled numerous new features on Ganymede's surface, including impact craters up to 100 kilometers in diameter. We missed several truly massive impact craters that we simply couldn't see in Voyager's data. Scientists declared, "This should serve as a cautionary tale against attempting to map a world based solely on one image and one lighting angle. We missed this large 100-kilometer wide crater that is clearly visible in Junocam's data, and we missed another slightly less obvious one measuring about 110 kilometers. The images also revealed several smaller craters with widths ranging from 40 to 50 kilometers and numerous features that, according to scientists, could be the result of volcanic activity on Ganymede. We discovered features resembling calderas similar to those previously seen in other parts of Ganymede. Calderas are volcanic craters that were likely formed by cryovolcanoes erupting frozen water and gas from beneath the moon's surface. The quantity of these features observed in Juno's images indicates a much more intense volcanic activity on Ganymede than scientists previously expected. This certainly leads us to think that we have underestimated them so far, and there may be many more on Ganymede. When we obtain new data, Ganymede is not only the largest satellite in the entire solar system, but it is also the only known satellite with its own magnetic field. Changes in its magnetic field led scientists to conclude that Ganymede must have a massive subsurface ocean of salty water, with depths of up to 100 kilometers, concealed beneath an ice and rock crust up to 150 kilometers thick. This ocean makes Ganymede one of the prime candidates for the existence of primitive life forms. Being about 1 million kilometers away from Jupiter, Ganymede is surrounded by the magnetic field of this gas giant, as well as its immense gravity that attracts passing asteroids and comets. The interaction between Ganymede's and Jupiter's magnetic fields produces vibrant polar auroras on the satellite. Ganymede's polar auroras are the only such phenomena ever observed on a moon. They were discovered in images obtained by the Hubble Space Telescope, but the recent flyby of Juno allowed scientists to gather more information about these shimmering spectacles. "Now we have been able to see the precise locations of auroral emissions," said one of the researchers at the conference. "We were able to see the latitudinal extent of the polar aurora, and we see very sharp boundaries at the polar edges of both auroral ovals, whereas the emissions taper off more, gradually as you move toward the equator. Therefore, future models will need to explain this." The end will be the main goal of the upcoming European mission to study the icy moons of Jupiter, whose launch is expected soon, planned for April of this year. Besides Ganymede, this is an automated interplanetary station designed to explore the Jupiter system. It will study the moons Europa and Callisto, and its main focus will be to investigate the presence of subsurface liquid water oceans on these moons. Callisto is a large moon orbiting Jupiter with an ancient cratered surface, indicating that geological processes may be dormant. However, it may also harbor a subsurface ocean. It is unclear if life can exist in the ocean because the surface is very old, so more observations are needed for this large moon. The upcoming mission, called JUICE, Jupiter Icy Moons Explorer, will focus on 3 icy moons of Jupiter, including Callisto, to gather more information about their environments. JUICE is expected to enter Jupiter's orbit in 2031. Currently, there is a mission to Jupiter called Juno. Although Juno is primarily designed to observe Jupiter's atmosphere and environment, it has captured several images of Callisto and other icy moons of the solar system from a large distance. In recent years, other icy moons have received attention from researchers due to their potential for life. The Cassini spacecraft, which orbited Saturn from 2004 to 2017, discovered extensive evidence of geysers on its moon Enceladus. Other icy moons include Triton, orbiting Neptune, and Europa, another icy moon of Jupiter. Overall, these moons sustain liquid oceans due to the gravitational pull of their giant planets. The 4 largest satellites of Jupiter, Io, Europa, Ganymede, and Callisto, are also known as the Galilean satellites, named after Galileo Galilei, who discovered them in 1610. All 4 are larger than Pluto. Among them, Ganymede is the largest satellite in the solar system, even larger than Mercury. When Galileo pointed his telescope at Jupiter on January 7, 1610, what he saw amazed everyone. The planet was not alone. It was surrounded by 4 moons. At that time, it was believed that Earth was the only planet with a moon. For 2 centuries, Jupiter's satellites were referred to as the Medicean stars, named after the powerful Italian political family, the Medici. The discovery had not only astronomical, but also religious significance. The Catholic Church supported the idea that everything revolved around the Earth, an idea put forth by ancient astronomers Aristotle and Ptolemy. Galileo's observation of Jupiter's satellites, as well as the discovery that Venus went through phases similar to our own moon, provided compelling evidence that not everything revolved around the Earth. However, as telescopic observations improved, a new perspective on the lunar planets emerged. They were not immutable and perfect. For example, mountains seen on the moon indicated that geological processes were occurring elsewhere. Furthermore, it was discovered that all planets revolved around the Sun. Over time, satellites were found around other planets, including additional satellites around Jupiter. The Medicean satellites were renamed Europa to avoid confusion in the mid-1800s. Callisto, approximately 4.5 billion years old, is roughly the same age as Jupiter. It is the most heavily cratered object in the solar system with minimal geological activity on its surface. The surface has not changed significantly since its formation by the first impacts 4 billion years ago. Callisto is the farthest of the Galilean satellites, orbiting Jupiter at a distance of about 1,880,000 kilometers. It takes approximately 7 Earth days for Callisto to complete one orbit around the planet. It also experiences less tidal influence than the other Galilean satellites because it orbits outside Jupiter's main radiation belt. Callisto is tidally locked to Jupiter, always showing the same face. With a diameter of 4,800 kilometers, Callisto is roughly the same size as Mercury and is the 3rd largest satellite in the solar system, after Ganymede and Titan. The average surface temperature of Callisto is 139 degrees Celsius. Although telescopes significantly improved during the space era of the 1960s, there was still limited knowledge about Callisto. According to a book from 2004 titled Jupiter, Planet, Satellites, and Magnetosphere, astronomers could tell that the surface appeared relatively featureless compared to Io and Ganymede. Callisto also had a low reflectivity and was known to have low density. Astronomers had not observed any signs of water geysers, leading them to conclude that Callisto had a rocky surface. Pioneer 10 and Pioneer 11 flew by Jupiter and its satellites in the early 1970s, but these missions did not provide much new information about Callisto, apart from what ground-based telescopes had already shown. It was the Voyager missions in the late 1970s that truly revealed a different picture. Density and temperature measurements of Callisto were refined and high. Solution surface images revealed details as small as 1 kilometer per pixel. In other words, the resolution was sufficient to detect impact craters. In reality, Callisto was heavily cratered compared to other moons. Some consider Callisto to be the most unexciting object of its size in the solar system. For more detailed observations, we had to wait until 1996, when the Galileo spacecraft made its first of 12 flybys of Callisto. Multiple passes by Galileo and higher resolution allowed for much more information to be gathered about Callisto than before. Large portions of the surface were mapped, revealing a tenuous atmosphere of carbon dioxide and evidence of subsurface ocean. Arguments in favor of an ocean stemmed from two pieces of evidence. First, scientists observed regular variations in the magnetic field around Callisto, suggesting the presence of an electrically conductive layer, which could be an ocean. This indicated that there were electric currents inside the moon stimulated by the planet's magnetic field. This flow had to come from somewhere, leading to the second part. Due to the rocky surface and tenuous atmosphere, a probable explanation was a salty ocean beneath the moon's surface. In 2018, a study of archival images taken by the Hubble Space Telescope in 2007 showed the influence of Callisto on polar auroras in Jupiter's atmosphere. Jupiter generates polar auroras on its own, but some phenomena occur due to interactions with its four largest satellites, Europa, Io, Ganymede, and Callisto. The signatures of other satellites had previously been detected in Jupiter's atmosphere, but this new study was the first to detect the Callisto effect. Callisto and the other Galilean satellites may have formed with the help of Saturn. A computer model released in 2018 proposed that as Saturn's core grew, its gravitational influence pulled the inner planets of the solar system inward. This process could have provided enough material for the formation of the four Galilean moons. Recent scientific research includes modeling the interaction of Callisto's magnetic field with Jupiter and detecting atomic oxygen in its atmosphere using the Hubble Space Telescope. The research provided further evidence of the existence of a subsurface ocean on Callisto. Other studies focused on aspects such as the potential presence of water beneath its surface, refining the number of craters on its surface, and studying its atmosphere to determine its suitability for life and how it formed. These unanswered questions will be addressed by the upcoming JUICE, Jupiter Icy Moons Explorer, mission, which is planned to launch to Jupiter in 2023 and will operate in the Jovian system for at least 3 years between 2031 and 2034. JUICE will primarily focus on Ganymede, but its scientific objectives for Callisto will be similar. This includes searching for layers of an ocean or water reservoir, mapping the surface, studying the atmosphere, and determining the interior structure of Callisto. As Jupiter's fifth satellite, Callisto is the most volcanically active body in the solar system, with its surface dotted with hundreds of volcanoes. Some of these volcanoes emit sulfur plumes reaching hundreds of kilometers in height. This volcanic moon is the third largest and the innermost of Jupiter's Galilean satellites. It is caught in a gravitational tug of war between Jupiter and its two neighboring moons, Europa and Ganymede. These tidal forces generate heat, which stimulates intense volcanic activity on the moon. Its surface changes at an incredible rate as volcanic fissures release lava onto the surface, filling impact craters and creating new liquid rock float. While the exact composition of the satellite is unknown, it is likely composed of molten sulfur and its compounds or silicate rock. Additionally, the thin atmosphere of the moon mainly consists of sulfur dioxide. Io, the fifth moon from Jupiter, has an average orbital distance of approximately 422,000 kilometers and completes an orbit around Jupiter in 1.77 Earth days. It is tidally locked to Jupiter, always facing the same side towards the planet. Io has an average radius of 1 kilometers, making it slightly larger than Earth's moon. It has a slightly elliptical shape with its longest axis directed towards Jupiter. Among the Galilean satellites, it ranks third in size after Ganymede and Callisto. but surpasses Europa in terms of mass and volume. The average surface temperature of Io is approximately 130 degrees Celsius, leading to the formation of sulfur dioxide snowfields. However, the volcanoes on the Moon can reach temperatures of up to 1650 degrees Celsius. It is often referred to as a celestial body of fire and ice. When Jupiter and Earth are on the same side of the Sun, the distance to Io can be as close as 588 million kilometers. At maximum distance, it can reach 968 million kilometers. The volcanic activity of the satellite was first discovered by the Voyager missions in 1979. The Moon's volcanism is driven by powerful tidal forces as it orbits Jupiter on an elliptical path. The gravitational force exerted by Jupiter on the Moon varies depending on its proximity to the gas giant. These gravitational fluctuations constantly push and pull the inner part of the Moon in different directions, causing the Moon's surface to bulge by about 100 meters. This movement forces Io's rocks to rub against each other, releasing an enormous amount of heat, about 20 times more thermal energy than the Earth emits. If Io were the only moon of Jupiter, its orbit would likely have settled into a circle long ago. However, the ongoing gravitational interaction with Europa and Ganymede guarantees that this won't happen. The Moon cannot escape this eternal gravitational tug of war, resulting in continuous tidal heating. The atmosphere of Io, due to sulfur dioxide, is extremely tenuous, at about 1/1,000,000th of Earth's surface pressure. The Moon's orbit intersects powerful magnetic field lines of Jupiter, turning it into an electric generator. It can generate up to 400,000 volts and, in turn, creates 3 million amperes of electric current. It then travels along the magnetic field lines of Jupiter and triggers lightning in the upper layers of Jupiter's atmosphere. As Jupiter transforms its magnetic forces, it carries away tons of material every second, ionizing it and forming a donut-shaped radiation cloud called the plasma torus. Some regions are drawn into the upper layers of Jupiter's atmosphere, creating polar auroras. An example of this activity was discovered by the Hubble Space Telescope, which revealed the influence of Ganymede, another satellite of Jupiter, on Jupiter's polar auroras in 2018. Additional evidence of the interaction between the volcanic activity of Io and electric currents controlling Jupiter's polar auroras was discovered in a 2022 study. According to observations from the James Clerk Maxwell Telescope and the Texas Spectrograph, Io also has a tenuous atmosphere consistent of sulfur dioxide. This atmosphere freezes when the Moon is in Jupiter's shadow each day and turns back into gas when Io returns to sunlight. Scientists had long suspected the existence of this phenomenon, but it was only after this study, which observed the satellite's atmospheres in the dark, that researchers found confirming evidence. Io was the first of Jupiter's moons to be discovered by Italian astronomer Galileo Galilei on January 8, 1610. He had actually observed the Moon the night before, but couldn't distinguish it from Europa, another moon of Jupiter, until the following night. This discovery, along with the subsequent discovery of 3 other moons of Jupiter, marked the first time a moon was found orbiting a planet other than Earth. Galileo initially named this moon Jupiter I, but in the mid-1800s it was renamed Io after a priestess of Hera, Zeus's wife and daughter of Inachus, the king of Argos, in Greek mythology. Zeus, or Jupiter, fell in love with her but turned her into a cow to protect her from his wife Hera. Although no dedicated missions have been sent to Io, several spacecraft have flown by Jupiter and observed its moons. The first was the Pioneer 10 spacecraft in 1970, followed by Pioneer 11 in 1974, and later the Voyager probes. Voyager 1 and Voyager 2 made remarkable images during their flybys in 1979. From 1995 to 2002, the Galileo spacecraft conducted multiple flybys of Io and provided us with the closest views of Jupiter's volcanic moon to date. In 2000, the Cassini spacecraft studied Io during its flyby on its way to Saturn. Although there are no specific missions planned exclusively for observing Io, the Juno spacecraft currently in orbit around Jupiter will fly as close as 300 kilometers to Io in December of this year, providing valuable information for further study of this volcanic moon. We can look forward to new information about Io's volcanism in December 2023 or early 2024. And don't forget to subscribe to the channel to be the first to receive updated information on space-related topics. Europa, one of Jupiter's Galilean moons, along with Io, Ganymede, and Callisto, was discovered by astronomer Galileo Galilei, who gained recognition for the discovery of these moons, some of the largest in the solar system. Europa is the smallest among the four. However, it is one of the most intriguing satellites. Its surface is frozen and covered with a layer of ice, but scientists believe there is an ocean beneath the surface. The icy surface also makes Europa one of the most reflective bodies in the solar system. In 2012, researchers using the Hubble Space Telescope noticed a possible plume of water vapor erupting from Europa's southern polar region. After multiple attempts to confirm the observation, clear plumes were seen in 2014 and 2016. The researchers cautioned that the plumes had not yet been fully confirmed, but they speculate that water from Europa's ocean is being ejected to the surface. Several spacecraft have flown by Europa, including Pioneer 10 and 11 in the 1970s, and the Galileo spacecraft, which conducted a long-term mission to Jupiter and its moons from 1995 to 2003. NASA and the European Space Agency are planning missions to Europa and other satellites that will depart from Earth in the 2020s. Galileo Galilei discovered Europa on January 8, 1610. It is possible that German astronomer Simon Marius also observed Europa around the same time, but he did not publish his observation. Therefore, the discovery is mostly attributed to Galileo. For this reason, Europa and the other three largest moons of Jupiter are often referred to as the Galilean moons. However, Galileo initially referred to these moons as planets of the Medici family in honor of the Medici family. It is possible that Galileo indeed observed Europa earlier, on January 7, 1610, but because he used a low-power telescope, he couldn't distinguish Europa from another of Jupiter's moons until later. Galileo's observations of Jupiter's moons, as well as his discovery that Venus undergoes phases similar to our moon, provided convincing evidence that not everything revolves around Earth. However, as telescopic observations improved, a new perspective on the universe emerged. The moon, like planets, were not immutable and perfect. For example, the mountains seen on the moon indicated that geological processes were happening elsewhere. Additionally, it became clear that all planets revolved around the Sun. Over time, more satellites were discovered around other planets, including additional satellites around Jupiter. Marius, another early discoverer, proposed giving the four moons their current names from Greek mythology. However, it was only in the 19th century that the moons were officially given the so-called Galilean names by which we know them today. All of Jupiter's satellites are named after lovers or victims of the god Jupiter, depending on your perspective in Greek mythology. Europa was abducted by Zeus, the Roman counterpart of Jupiter, who took the form of a perfect white bull to seduce her. She adorned the bull with flowers and rode on its back to Crete. One distinctive feature of Europa is its high degree of reflectivity. The icy crust of Europa gives it an albedo, or light reflectance, coefficient of 0.64, which is one of the highest among all satellites in the entire solar system. Scientists estimate the age of Europa's surface to be between 20 and 180 million years, making it relatively young. Photos and data from the Galileo spacecraft suggest that Europa is composed of silicate rock and has an iron core and a rocky mantle, similar to Earth. However, unlike the Earth's interior, the rocky interior of Europa is surrounded by a layer of water and ice, with a thickness ranging from 80 to 170 kilometers. Due to the fluctuations in Europa's magnetic field, which suggest the presence of a conductor, scientists also speculate that there may be an ocean deep beneath the moon's surface. In this ocean, there could be some form of life. The possibility of extraterrestrial life is one of the reasons why interest in Europa remains high. In fact, recent studies have revitalized the theory that Europa may be capable of supporting life. The surface of Europa is cracked, and many believe that these cracks are the result of tidal forces from the ocean beneath the surface. It is possible that when Europa's orbit brings it closer to Jupiter, the tidal pull causes the ocean beneath the ice to rise higher than usual. If this is the case, the constant lifting and lowering of the ocean may have caused numerous cracks observed on the Moon's surface. Obtaining samples from the ocean may not require drilling through the icy crust if the observed plumes turn out to be actual jets of water, while researchers found evidence in 2012, 2014, and 2016. The true nature of the plumes and why they appear sporadically require further observation. In 2014, scientists discovered that Europa may have a form of plate tectonics. Previously, Earth was the only known body in the solar system with a dynamic crust, which was considered crucial for the evolution of life on the planet. The presence of water beneath the frozen crust of Europa leads scientists to consider it as one of the best places in the solar system with the potential for life. It is believed that the icy depths of the Moon contain vents in the mantle similar to the oceans on Earth. These vents could provide the necessary thermal environment for life to develop. If life exists on Europa, it may have received a boost from comet deposits during the early stages of the solar system's existence. Icy bodies could have delivered organic material to the Moon. In 2016, a study revealed that Europa produces 10 times more oxygen than hydrogen, similar to Earth. This could make its potential oceans more conducive to life compared to other icy moons. It is possible that tidal heating is not necessary to generate sufficient energy. Instead, chemical reactions could be enough to drive a cycle. In 2013, the National Research Council of the United States published a 10-year recommendation for the Planetary Science Program of NASA, ranking the exploration of Europa as a mission with the highest priority. Since then, NASA has been working on a mission to the icy moon of Jupiter. In 2017, the mission was officially named Europa Clipper, after several years of unofficial use of this nickname by researchers and the media. According to NASA, this mission, which is expected to launch in the 2020s, possibly in the late decade, will perform around 40 to 45 flybys of Europa with a spacecraft. On board, there will be 9 scientific instruments, including cameras and radar to peer beneath the ice and attempt to determine its thickness, a magnetometer to measure the magnetic field and, consequently, the salinity of the ocean, and a thermal imager to search for signs of eruption. The altitude of the flights will range from 25 to 2,700 kilometers, which leads to flybys passing through Europa's radiation-heavy zone, making it challenging for the spacecraft to survive. Therefore, withdrawing the spacecraft from this zone will extend its service life and facilitate data transmission back to Earth. One of the priorities of the Europa Clipper mission will be to continue observing the plumes, provided their existence is confirmed, and they are associated with the subsurface ocean. Studying their composition will help scientists explore the potentially habitable chemical environment of Europa, minimizing the need for drilling through layers of ice, according to a NASA statement. The European Space Agency is also planning a mission to Europa and 2 other moons called JUICE, Jupiter Icy Moons Explorer, and Moons Explorer. It is expected that the mission will be launched in April 2023 and reach Jupiter's orbit in July 2031. Once it reaches Europa, the mission will study organic molecules and other components that could make the moon habitable. Additionally, the spacecraft will investigate the thickness of the icy crust, particularly over any active regions it encountered. This was a videos of Jupiter's moon Europa. I hope you enjoyed it, and please don't hesitate to like the video and leave your comments or opinions below. Wishing you all the best in space exploration. Goodbye.